Hi, I'm David from ARDEN PHOTONICS. I just wanted to give you a brief introduction to our FGC fiber geometry system. First of all, let me just share my screen with you. There we go. But first of all, for those of you who are less familiar with ARDEN PHOTONICS, I'll just say a few words of introduction. I founded ARDEN 20 years ago. We have our headquarters in Birmingham and an office in Clearwater, Florida. Together with our network of sales partners today, we sell our products in over 35 countries worldwide. We have a very active product development team with a wide range of skills. Our product development is definitely customer driven. We often produce specific test solutions for our customers. One area where we are considered to be leaders is in the measurement of optical fiber geometry of specialty fibers. Quick and accurate measurement of fiber geometry is essential for manufacturers and users. Typically, measurement accuracy and repeatability in the range of 100 nanometers is required to ensure cabling, connectorization, and splicing are trouble-free. Our flagship product in this range is the FGC GA. It's capable of measuring everything from standard telecom fibers, specialty fibers up to 1 millimeter in diameter, MT ferrules, and V grooves. I'll just now highlight some of the novel features which the FGC GA offers. Optimizing dual wavelength illumination at both the launch and receive allows for clear definition of the core by eliminating light in the other guiding structures. At the same time, non-circular structures can be analyzed, and parameters describing the octagonality of the fiber, for example, can be presented. The flexible options of the FGC GA also allow comprehensive measurement of polarization maintaining fibers. This slide shows the measurement of a Panda-style PM fiber. The stress-applying parts in this fiber are doped with boron, which absorbs the transmitted light very strongly. So in order to make them visible enough to be measurable, a special illuminator is required called the PMI. This optional accessory is mounted close to the tip of the fiber under measurement and injects light into the cladding. With the structure correctly illuminated, the measurement of all the parameters of the fiber can be quickly and automatically measured. This includes the diameter of the stress rod and the orientation of the rods with respect to the core. Another important application area for the FGC GA is in the measurement of V-groove arrays. Once again, comprehensive analysis is built in as standard, which can provide core-to-core pitch, X to Y offset, and even measurement of the V-groove array itself. Using image stitching techniques, the FGC GA can offer many advantages, including measurement of extremely wide arrays, the automatic characterization of PM alignment within an array. A tiltable holder allows users to measure facets with not only 0 and plus or minus 8 degree angles, but any angle in between to allow for accurate measurement of customized arrays. In conclusion, we believe the FGC offers a complete solution to the measurement of glass geometry. With traceable calibration performed using NPL's golden fibers, the FGC can offer quick and repeatable measurements of a very wide range of optical fiber structures. Thank you for your attention.